So with the clamp to constraint, this is the first constraint where we actually need a secondary object for it to work. And that would be a curve object, and it has to be a curve object for this to work. We are clamping our control to a curve. So how do we get this active? Well, there is a shortcut. You can select the target curve first, then shift select the actual armature, but then while you still have it selected, jump into pose mode and make sure that you have an active bone, which in this armature I only have one bone, and it's called owner. So with that active, we can use our shortcut, Control Shift C, and then choose clamp to. So what this has done is it's clamped the head of the bone to a position along that curve. And over here, we can have a look at our constraints. So this is our target object. That was the target curve there. Then we have the main axis. So we have the auto, X, Y, and Z. And this is the main movement that we want it to work along. So this means if we move our bone, I'm just going to grab it now, it's going to be pinned to that curve, and it can't go anywhere outside that. You can still rotate it around because this constraint doesn't actually do any like a rotation. It's just taking control of the location, and that location has to be on the curve. Now the main axis is based in world space. So I'll just change my manipulator to be global so you can see what I mean. The auto will do its best to figure out what axis it thinks that you want it to move on. I think it will choose the X, yeah, it chooses the X axis for this one. So that means if I move it in the world X, it's just going to be pinned along the length of that curve. Now, if I change this to be X, you'll see it happens to be the same, it's the same effect there because that's what the auto was choosing. Now the Y will be when I move it on the Y axis, you can see it's now running forward to backwards on that curve. And if you change this to Z, it's going to be the up and down is going to move it from the front to the back of that curve. Now the cyclic option will mean when you get to the end, it's going to loop back to the start. So you can keep going up and up and up and up and up and up. So that's the way that that one works. And you can even jump into the curve here, edit, and then make this one cyclic. Curve toggle cyclic. And now you can see it's actually looping. And when we grab our bone, let's leave it on auto so it goes on the X. You can see it's just going to go around and around and around and around infinitely. So I'm guessing this could be handy in many circumstances, although I haven't actually had to use this constraint very often in any of the rigging that I have done. So now we're going to look at the follow path constraint. Now this is one that also requires a curve object for it to work. Now before I go any further, this is the default orientation of our bone, but just to make it a little bit easier as we're going on, I'm going to rotate our bone in edit mode so that its local coordinates matches world space. So just jumping into edit mode, changing the orientation point, and then rotating it -90 degrees. Now the Z-axis is pointing up, the Y-axis is pointing with backwards, and the X-axis is pointing to the right, which matches world space. Okay, so now I'm going to add our constraint. We can do that by selecting our curve object, shift selecting the armature object, and then jumping into pose mode and making sure that we have the bone active that we want to add the constraint to. Now we can hit Control, Shift, and C, and then choose our constraint, which is the follow path. And you'll notice that it's jumped from its position over here to the start of the path. Now let's have a look at our constraint over here. So it's all set up. Let's have a look at some of the settings here. So the offset value, so 0 is at the start of our curve. And if I drag this backwards into the negative values, it's going to go all the way to the end. And because my curve happens to be 100 frames long, when I drag it to -100, it's going to get all the way to the end. Although of course I can drag it past, but it's going to stop there. And that is because I'm just using the default settings of the curve here when I added it. So that is if you wanted to use the length of the curve. If you want to use an alternate way of doing that, you can activate the fixed position, and then that changes it to an offset factor. And this works as a percentage. So 0% is at the start of the curve, and 1 is 100%, or the end of the curve. And anywhere along here is a percentage. So 0.5 is the halfway mark, or 50%. That is how you edit that. Just put it back to the start and disable that, and you can see it's changed back to our other settings. So let's just also reset that. Now it actually only affects the location. It doesn't take full control of that. So we can actually still move it along. And if we actually translate it, it's going to move relative to this offset here. And the same thing with the rotation. So we can actually still rotate this one, although by default, it won't actually try and follow the curve with the rotation. To do that, we need to enable the follow curve. But let's just reset everything to kind of make more obvious sense. So when we hit the follow curve, it's going to change the orientation of our bone to match our settings here. So we can tell it what axis that we want it to follow along. So by default, it is the y-axis. And that is why I changed the orientation of our bone to match world space, just to make it a little bit easier. So the positive y is the length of our bone, and then the up axis is going to be the z-axis. So that is going to be the way that it points up. Now, it is not the world up, it is up according to the twist of our curve. So let me just show you. If I drag this, say, to this point, and I edit our curve, so I'll jump into object mode and then edit mode for our curve, I can actually change the tilt here, and you can see our bone is actually spinning around. Now, what does that mean? So that means when we animate along here, you'll see that it also twists as it goes past that point. So that's what the follow curve does. Now, the follow radius is a similar thing, but we can actually change the scale of our bone based on the radius scale of our curve points. So jumping back into edit mode again, and you'll see this point here has a radius, and it is multiplying the scale by 1, which is no change. But let's just say change this to 5, and you'll see our bone is getting really big. All right, so now when I animate it, I will just slide here. You can see when it gets to that point, it's going to scale up and scale down. And that's what the curve radius does. And the one last thing that I want to show you is the animate path. So I've been dragging this around to actually move it. And if we actually drag the frame range around, you can see that there's no animation here. But if we click this button, it's going to add animation to our curve here, and it is going to follow along with the animation. So now you're not moving our control with the offset value anymore. You're actually controlling it with the animation data of our curve. Although the offset value will still do as the name suggests, it will offset your control by the offset value. So hopefully that makes sense there. But when you add the animation, the movement is controlled by the animation data. But that is the follow path constraint. I hope you find it useful.